Greetings, welcome to the discussion question on logarithms. In particular, this is Logarithms Introduction to the Relationship. Some of this material comes from a nice website called Purple Math. I invite you to go there and take a look at the entire write-up if you would like more work with this. So let's go through and see if we can breathe some life into what has been posted on that website. Logarithms are the opposite of exponentials, just as subtraction is the opposite of addition and division is the opposite of multiplication. Logs undo exponentials. One undoes what the other one did. Technically speaking, logs are inverse functions to that of exponential functions. We'll talk about that a bit more as we work through here. In practical terms, it's useful to think of logs in terms of what Purple Math refers to as the relationship. What they say is that y equal to b to the x is equivalent to, which means it says exactly the same thing as logarithm base b of y is equal to x. So in Geek, we would read the right-hand side as log base b of y equals x. In English, which is sometimes versus Geek, an easier way of thinking about it, the logarithm can be pronounced as the exponent on base b that yields y is x. The value of the subscripted b is the base of the logarithm, but it is also the base of the exponential. And just as with the exponential, the base b is going to always be positive and it's not going to be equal to 1. So that's going to be true for logarithms too. The base will always be positive and not equal to 1. Whatever's inside of the parentheses in the logarithm is referred to as the argument of the log. Notice that the base b is the same whether you're running in the exponential form or the logarithmic form. But what happens is the x and the y swap places. And you're going to want to remember that relationship. That's going to be extremely important. Okay, let's go work some problems with this. Enough yakking. Let's go actually do some problems and see if we can make this make some more sense. So let's take a look at the following exponential expression. If I gave you 5 raised to the third power, that's going to be equal to 125. In other words, I take 5 times 5 times 5, that gives me back 125. Well, the equivalent logarithmic expression, or the way you would write that as a logarithmic equation here, would be, by the way, the double whammy equal or arrows there mean that it's the same no matter which way you're looking at it here. Well, let's see, the exponent, that's how I usually say the word log, the exponent on a base 5 that yields 125 is equal to 3. So let's take a minute and ponder that. Let's check out what just happened here. Notice that what we did is we solved the equation for the exponent. The exponent is now down here where it's solved and isolated off to the right-hand side by itself. And that's one of the big usefulnesses for logarithms, because many times we have a variable in the exponential place and we'd like to get that variable isolated, and logarithms allow us to do that. The other thing to notice or to keep in mind here is that this value right here, the base, is going to be the base. Those parts didn't change. What did change is that the 3 and the 125 traded places, basically. That's kind of what Purple Math is trying to explain to you. Let's try another one. Let's do 2 to the negative 3. Well, we know 2 to the negative 3 because we've done our review of exponents is going to be 1 over 2 cubed, and 1 over 2 cubed is going to be equal to 1/8. So if you don't remember that, it might be a good time to pause and go back and do your review on your exponents. Okay, so let's label these so we have some labels here to work with. So in part B here, we want to go ahead and turn that one into a logarithm also. So how would we do that? Well, to write that as a logarithm, that would say the exponent on a base 2 that yields 1/8 is equal to negative 3. So the cool thing to remember is what the logarithms do is they take and they solve it into the exponent. In other words, the exponent gets isolated onto one side of the equation. Let's try one more where we go from exponential to logarithm, and then we'll switch and we'll go from logarithm to exponential. Let's do a simpler one here. Let's say we had 3 squared was equal to 9. Well, oh, that's a true statement, but what would that look like as an exponential? Well, that would say that the logarithm base 3 that yields 9 is equal to 2. That's saying it in geek. Saying it in English would say the exponent on base 3 that gives me a 9 is 2. Hopefully making big sense. All right, let's try going the other direction now. So let's start off with the logarithm and let's see if we can get that back into an exponential. All right, so what if we had logarithm base 2 of 16 is equal to 4? Well, what does that mean? Let's read that in English and see if we can get that to work out. Well, that says that the exponent on a base 2 that gives me 16 is equal to 4. Let's do another one. What if we had logarithm base 6 of 36 is equal to 2? Well, what does that say? Well, that says the exponent on a 6 that gives me 36 is equal to 2. Let's do one more, and then we'll call this good. Well, if I said the exponent, or the logarithm, base 5 that gets me 1 over 125 is equal to negative 3. Well, let's see, what does that say? What would that say as an exponential? It says that the base 5, the exponent on a base 5, that gets me 1 over 125 is negative 3. Okay, so one of the ways to conquer this material is to just by repetition. The more this you do, the easier it gets. So don't be shy about working more than just the problems that have been assigned or looking at additional resources. Also, there is an ancillary topic in here, which is the idea of an inverse. And the idea of an inverse, which is a very important idea, is not covered very clearly in our textbook, so I've given you a link to additional resources from Khan Academy. If you're moving on into college algebra, I strongly recommend that you take the time and watch those videos. But just to give you kind of a heads up on that, let's do an example of what we mean by an inverse. Basically, what an inverse means is that you are swapping the ordered pairs. So really, the main idea of that is you swap x and y. So when you see the word inverse, think swap x and y, and you're going to be in pretty good shape. So for example, if I wanted to know what the inverse function of f of x equal to 3x minus 11 was, so in other words, what is the inverse to this? Well, I would come down here and I think, okay, well right now I'm given y is equal to 3x minus 11. If I want to find the inverse, then what I do is I say x is equal to 3y minus 11. Well, there's my inverse, but typically we're going to want that solved for y. So if I solve that for y, that's going to be x plus 11 is equal to 3y. And now if I divide both sides of that by 3, I get x plus 11 over 3 is equal to y. So this new function that I've created is going to have this notation on it. F inverse of x is equal to x plus 11 over 3. And what that is, these two functions undo each other. In other words, if I plug, for example, a 2 into f of x here, I'll get back 6 minus 11, which will get me back negative 5. If I plug a negative 5 into this function, it'll take me back to the 2. All right, hopefully I've piqued your interest on the idea of inverse functions. I refer you to those glorious Khan Academy videos if you want to learn more about it.